Um, in this video, we have focused about property of fluids. Um, so, why we are studying the fluid mechanics and their importance? Because of the fluid mechanics only deals with the fluid motions and rest conditions also. And this knowledge essentials for designing and operating and optimum systems for the learning engineer uh, and the importance of the fluid mechanics. So this is very important for the coming follow the section and the foundations of engineering system and this is designs and the safety and engineering and the power generation, industry and the process application, environmental and biological system and the performance optimization and the everyday life application also. These mechanisms mostly important for the water supply system, pipeline and the pumping and turbine compressors and hydraulic machine because of the basic fundamentals. So how will we transfer the fluid to other type of the energy? So the energy how will be utilized in the various section and without losses how will be applied in the power generation and the various process applications and the separation heat transfer and the mass transfer process and the environmental application for the wastewater treatment and the blood flow analysis and the biomedical device designs and everyday life applications such as air flow around the vehicle and the weather patterns. These are also involved by the fluid mechanics. So these videos we follow this content. The first introductions about mechanics and the fluids and the property of the fluids, density, specific weight, specific volume, specific gravity, and the vapor pressure and the viscosity, kinematic dynamic, and Newton law of viscosity. One of the factors affecting the viscosity. So the first introduction is about the mechanics. Mechanics means what? The stationary components will be moving along with the boundary condition. That is also mechanics. So this mechanics mostly it should be considered the body will be static condition. It is a static statics and the bodies will be movement conditions called as a dynamic also. So this fluid mechanics behavior of the fluids will be rest condition and the motion with respect to days and the interactions will be occurs fluids with solids or others within the boundary also. So here the fluid will be defined in these two cases. Only is this liquid and the gases also. So generally, this matters will be classified two cases. One is a solid and the fluid. So this also will be differentiated by the stress strain relationship and the elasticity also. Stress strain analysis mostly follow in the Hooke's law in a solid matters and in a liquid matters will be considered Newtonian law of viscosity. So the stress strain analysis relationship mostly this is solid means what that is a recurring external forces to causes it to this deformation. The deformation occurs mostly in the solid body. What will happen? The deformation will be occurs. The shape also will be changes there. But in a liquid, what will happen? The solid base with the um, a different shape, but we will take the waters or some other liquid, it will be converted as a container of the shape. So the container will be different shape of means a different shape of we are getting the liquids also, right? So with respect to here, so will be classified as two. One is a combustible force, a combustible, incombustible liquid also. The combustible liquid means what here this. So example you take air, this will be combust. Density and volume also will be changes. So each also will be affected by the temperatures and the pressure. What will happen? Then fuel also will be changes that. But in a non-compulsive, example water, it will not be affected that, right? So here these fluid mechanics also will be defined in this three cases: the static fluid and the dynamic fluid and the kinematic fluid also. Static means fluid will be ideal condition. Kinematic means only consider the fluid velocity and the accelerations, but the dynamic we consider the fluid and the motions also. Property of the fluid. So now we will focus on the density, specific weight, specific volume, specific gravity, viscosity, and the vapor pressure and the surface tensions. So measurable quantity is called as a property. So how will be measured here? This the first one is a density. Density means what? Mass per volume, right? So normally mass per volume is a density, but in a fluid, how to explain here? Density means a fluid density means a density of liquid by density of uh, mass of fluid by volume of fluid. That is a density, right? So density means what? Mass of fluid by volume of the fluid. Here, this mostly the symbol is the arrow. Then the unit is kg meters cube. Specific weight means weight of the fluid by volume of the fluid. So here there's weight means mass by volume of the fluid. So you apply here this, you get the value. So density into gravity force. It is specific weight. So normally it is how to define this between the weight of the fluid to volume of the fluid. So again, the specific volume means per unit mass how much volume will be occupied. That is called as a specific volume. It is defined as the volume of fluid occupied by the unit mass. So that unit is specific gravity. How to define this? Yeah, specific gravity. So basically gravity means density of fluid by density of standard liquid. Density of standard liquid means it is a water. Water means you take a 1000 kg per meters cube. Suppose 700 kg per meters cube is given for the given fluids, means you take a specific gravity. How much? How to find? So 700 divided by 1000, 0.7. That how to this is a calculations procedure. So that type of fluid specific gravity 0.7. Same thing, vapor pressure also how to calculate or cavitation. And this mostly this vapor pressure means it is a pressure exerted by each vapor in equilibrium, base equilibrium conditions within a liquid at a given pressure or given temperature. It is identical to the saturation pressure of the liquid. So mostly these are high vapor pressure, vapor evaporation will be fast, low vapor pressure, this evaporation also very low. So partial pressure, how to calculate this? Mostly the pressure of the gases are vapor in the mixture with alone with other gases. For example, atmospheric air in the mixtures of the dry air and the water. So vapor. So and the atmosphere pressure in the sum of the partial pressure of the air and the partial pressure of the water vapor. This is a partial pressure. So saturation pressure calculate here this and the pressure at which the pure substance changes phase and the given temperature. So that the temperatures at which the pure substance changes the phases at a given pressure is called as a saturation temperature. So it is given the table. So the temperatures will be varying. What will happening at this vapor pressure will be very high. So the 100 degrees Celsius corresponding to water 101.3 kilopascal. So that the water vapor increases with the temperature. Okay, temperature increases means water vapor, water pressure increases. That. So this problem is given. Calculate the specific weight, density, specific gravity, and 1 liters of the liquid. Where weight is 7 Newton. So here 7 Newton is given. Specific weight to calculate as density. Density means W by G, and specific gravity. Also density of liquid, density of standard liquid. You put the value find out. Okay. So now you know here there's yes, and this is Newton 7 Newton, right? 7 Newton. So now you know here this weight equal to 7 Newtons. This value 1 by 1000s. You know. So next W by G, G by 9.8, W value is 7 so 713. Next the density of liquid 713.1, density of water is 1000 you are putting this value find. Okay. So next is a calculation of density, specific weight and specific weight and weight of the 1 liter of the petrol of liquid gravity 0.7. So in this case, here this density, calculate how to calculate density specific gravity equal to density of liquid weight, density of standard liquid. So already is given this like 0.7. So cross multiply 1000, what we have is 700. So WG also calculate specific weight 6867. Next, this weight equal specific weight equal to weight by volume. So you find the weight, basically weight also calculate for this 6867 multiply volume 1 liter, so 1 by 1000. So cross multiply, so how much value? 6.867 also this. Okay, this is a second problem here. Next, viscosity. Viscosity mostly how to calculate. So mostly we follow is one of the few property. So these offer resistance to the movement of the one layer of the liquid over another adjacent layers of the liquid. So mostly these H's directly proportional to du by dy. This is a Newton law of viscosity. So here this is tau equal to nu dou u by dou y. So here nu is here what this here kinematic dynamic viscosity. Nu is a dynamic viscosity. Du is a changing of the velocity and dy is a changing in distance and tau is a CHS. So now you know here this dynamic viscosity. Viscosity is a measure of the fluid resistance through internal shear resistance. So this unit Newton seconds per meter square. So same thing tau equal to nu dou u dou y. This is a Newton law of viscosity here. This and kinematic viscosity of the liquid, the ratio of its dynamic viscosity to intensity nu by rho here. Okay, so next this is a factor affecting of the viscosity. Mostly the temperatures affect the viscosity of the liquid due to variation in molecular of momentum transfer. So mostly example in the engine bike oil also you take every 2000 kilometers once you change the engine bike oil. Why? Due to reason the viscosity will be affected that. Otherwise what will happen? The problem will be occurs inside the engine also. So here this is liquid and the gases, both cases you calculate dynamic viscosity. Nu equal to nu naught 1 by 1 plus alpha t beta d square. So same thing here also here gases also calculate here this. So with respect to both value also will be changes, right? So here this with respect to here type of fuel also calculate ideal fuel, real fuel, Newtonian fluid. Ideal fuel means what here this and this is no viscosity. Real fluid means what there is having some viscosity. Example kerosene, petrol, oil. Newtonian oil means what there is a tau directly to du by dy, right? So here there's velocity gradient. So that less than this. So that is a Newtonian fluid. So it is obey the rules. Tau equal to nu dou u by dou y, right? So it's not means not Newtonian law. So ideal plastic fluid means is more than yield value of the shear stress is proportional to shear strain. So mostly this value just put the planters in the graph xy, so you get the value graph like this. Ideal flow in a x-axis, y-axis and a ideal solid. So these are ideal plastic flow with respect not touching in the x-axis, y-axis. So this is a profile on the origin to going non-Newtonian flow. Newtonian flow is going the straight line only. So like that is moving. So next this problem I think we will discuss in the next video lectures. Thank you.